Good evening, students.
Good evening, sir.
Good evening, Jai Shri and Shruti. Good evening.
Good evening, sir.
Good evening. Yeah. So we'll wait for a few more minutes to see if someone else joins. Okay.
Okay, sir.
Okay. Good evening, Xavier.
Good evening, sir.
Yes. So we'll wait for a few more minutes. Okay. To see if somebody else joins. Okay. Good evening, Vishwash Suresh. Good evening.
Good evening.
Welcome to the class. Okay. So I think previously we have completed units and dimensions. Okay. Right.
Yes, sir.
Yes, sir.
Yes, okay. So today we'll start with kinematics. Okay. Can you see my screen?
Yes, sir.
Okay.
Yes, sir.
So my screen is visible? Okay. Okay. Just a moment. Okay. So is the screen visible? My voice
Yes,
is
sir.
clear? Okay, okay. So today we are going to, discuss the chapter about kinematics. Okay. Kinematics. Okay. So it comes under the branch of mechanics in physics. Okay. Branch of mechanics in physics. Okay. And yes, so in kinematics you have two chapters. What are they? Motion in a straight line. Okay. Motion in a straight line. Another chapter is motion in a plane, right? So we are dealing with kinematics, right? So kinematics has two chapters. Okay. So it is motion in a straight line and motion in a plane. Okay. So what is kinematics? Can anyone tell me? Can anyone tell me what is kinematics? Who are there actually? Just a moment. So let me get who are attending. So there are Jayashri, Shruti, Vishwa, and Xavier. So can anyone tell me? Do you have any idea about kinematics? What about
It
Shruti?
is with some moving objects, sir.
Excuse me, ma?
Sir, will
Yeah.
it be with some moving object like that, sir?
Yeah. Like motion. When we say motion, it involves the motion of an object, right? So whenever we say motion, it involves some motion of an object. So that is okay. May I know who's this?
Axilia, sir.
Auxilia. Okay, okay. So kinematics. Thank you, Auxilia. Okay. So kinematics nothing but a study of, okay, study of motion of objects. Okay, study of motion of objects. But you know, study of motion of objects. Nothing but not only motion of object, description of the motion of objects. Okay, description of the motion of objects. For instance, if I say that a car, like an object has moved from here to here. Okay, an object has moved from here to here. Okay, so what we will study in kinematics is, we'll describe this motion, the object's motion, no? Okay, we'll describe this object's motion. Okay, so that's what kinematics is all about. Just a moment. Yes, good evening, Disha. So that's
Good
what.
evening, sir.
Good evening, ma. So kinematics is all about what? The description of a motion of an object. Okay, the description of motion of an object. Okay, so in kinematics we'll just describe describe the object's motion. Okay, we don't go into the causes of the motion. You understand? So we don't go into what caused the motion. For example, the earlier example, the object has moved from here to here. Okay, this is the initial position and this is the final position. So we don't go into, when we are dealing with kinematics, we don't go in detail about what caused this object to move from here to here. Okay, instead we'll describe this motion. Okay, we'll describe this motion in terms of, as you already know, speed, velocity, right? Distance, displacement. So, and average speed, average velocity, acceleration, so likewise. So kinematics is about the description of a motion of an object. You get my point? Disha, you just joined now. So what about Auxilia and Jayashri and Shruti?
Yes, sir. It's clear, sir.
Understood, sir.
Okay, so you get my point, right? Okay. So what are the two chapters in kinematics?
Motion in a straight line,
Motion in
motion
a
in a
straight
plane,
line
sir.
and motion in a plane. Very good.
In a plane, sir.
So today we are going to see about motion in a straight line. Motion in a straight line. Okay. So motion. Okay. So motion is something that we see in our day-to-day life, right? Like whenever we we go to the road or something like that, we see cars moving, right? Cars, vehicles moving, and even people moving, right? So motion is very familiar with us, right? So likewise, everything is motion. Even even in our veins, in our body, the blood, it flows through the veins, right? The arteries and veins. So it is in motion inside the veins and arteries. Okay. So another example of motion could be even our breathing, right? Our breathing is a motion, that air moves in and out of our nostrils, right? And what else could it be? Even dams, right? Dams, that is, the water flows through the dams, no? So that is also a kind of motion. And also in trees, even if the leaf is falling from a tree, that is also a motion. Okay, so motion is something that we see in our daily life and we are familiar with. Okay, like right from the beginning when we are born, okay, till now, and even in the future, like every day and every second we'll see the motion, right? So that is what. So how to define this motion? How to define this motion? You know the definition because you have studied in your earlier classes. That is like earlier grades 8th, 9th, 7th. Even in 7th you will have come across this, right? So what is motion?
Movement of an object from one place to another, sir.
Yes, very good. So movement of an object from one place to another. So this movement is nothing but a motion, right? It's nothing. The thing that you said, that is the movement. Okay, movement is nothing but another word for motion. And again, who's that? Auxilia, is it?
Yes, sir.
Okay. So movement is nothing but another name for motion. Okay. I'm asking what is motion? Like as you said, movement from one place to another. Okay. So I'm going on. Okay. I'm gonna go with what you have said. Okay. So movement from one place to another, right? So movement from one place to another. So what happens when a body or an object moves from one place to another? That's my second question. So motion is nothing but a movement. Movement means from one place to another place. Okay, good. And when a object or a body moves from one place to another, what happens? You can tell whatever you want. Okay, don't worry about whether it will be right or wrong. Okay, so just try it. What about the others? Only Auxilia is interacting. What about Jayashri is there? Shruti, are you there? Vishwa? Students?
Yes, sir.
Yeah. Again, it's I think Auxilia, right?
Yes, sir.
Okay, okay, no problem. So what happens when an object moves from one place to another?
There is some displacement, sir.
Displacement, very good. So there is a displacement. So nothing before go displacement is nothing but what? Displacement is nothing but change in position, right? Right, Auxilia?
Yes, sir.
Okay, so motion is nothing but change in position. Okay, so what is motion? Motion is nothing but change in position with time. Change in position with time. Okay, what is the definition of motion? Motion is change in position with time. Okay, so for example, change in position nothing but it is called displacement. Okay, change is nothing, change in position is nothing but displacement. Okay, they are relatable terms. Okay, so you guys are with me or not? Disha, Shruti, Vishwa, Jayashri, am I audible?
Yes, sir.
Okay, okay,
Yes, sir.
right. Okay, so what is motion? Motion is nothing but change in position with time, right? So for example, let's say an object is here. Okay, it moves in a straight line. Okay, an object is here and it moves in a straight line. Okay, so for example, let's say t is equal to 0 to 5 seconds. Let's say 0 to 5 seconds. Okay, 0 to 5 seconds, the object is here. At the 6th second, okay, it moves here. Okay, 7th second it moves here. This is the first initial position and this is the second position and this is the third position. So 0 to 5 seconds, what happens? Can you describe the motion of this object? What happens to that body from 0 to 5 seconds? The object is at rest, right?
Yes, sir.
Okay, so 0 to 5 seconds, the object is at rest. But at the 6th second, it moves from here to here. And at the 7th second, it moves from here to here. So what happens? It is in
Motion.
motion. So when it is in motion, what happens? There is a change in
Position with time.
position. Very good. So there is a change in position with time, right? So for example, I can write like this also. 5th second it is here. Okay. 6th second it has come here. 7th second it has come here. So there is a change in position from here to here, in here to here, with respect to time. This is 1 second, this is 1 second, and this is 1 second. So within that 1 second interval, okay, this is a 1 second interval, there is a change in position. You get my point?
Yes, sir.
Okay.
Yes, sir.
Yes. Okay. So the motion is nothing but change in position with time. Okay. So now we are going to deal with motion of objects moving in a straight line, moving along a straight line. Okay. We are going to deal with motion of objects moving along a straight line. Okay. So when we, so motion of an object moving along a straight line is otherwise called as, rectilinear motion. We can say it is motion along a straight line or motion in a straight line. In other words, it is rectilinear motion. Okay. And when an object is moving in a straight line, okay, when we are calculating, when you are calculating or describing, okay, when you are calculating or describing motion, okay, of an object, of an object moving along a straight line, okay, when we are describing motion of an object moving along a straight line, okay, we consider that object as a point. So for example, let's say this is the object, this box, no, this is the object. Okay, I think it will be in the next slide. Okay, I'll be here. Okay, so point out that is, when a body is moving along a straight line, say let's say this is an object and it moves along a straight line. Okay, so when we are calculating or describing the motion of an object moving along a straight line, okay, we consider that those objects which are moving along a straight line as points, as points. So I can write like this. Okay, I can describe this, this object's motion like this, that it is in a straight line path, or I can write like this. This is a point. Okay, that's the object. I can describe this object as a point. Okay, you getting what we are doing actually?
Yes, sir.
Okay, I'll explain it to you. That is, when we are calculating or describing a motion of an object moving along a straight line, that object is considered as point. So that is called as point objects. We'll call those objects as point objects. Let's say this is a box. Okay, so this box becomes a point object. This box becomes a point object. Okay, and there are two conditions. There are two conditions. Okay, to consider an object, two conditions to consider an object as a point object. Okay, first one is the motion should be along a straight line. The motion should be along a straight line. The motion of an object should be along a straight line. Okay, and the second point is that the size of the object, the size of the object, size of the object, okay, should be less than the distance. Somebody's coming now, just a moment. So the size of the object, okay, should be less than the distance it covers. So when to consider a object as a point object is, first condition is the motion should be along a straight line. The second condition is the size of the object should be less than the distance it covers. So we'll just we'll just look at this example alone so that you will get it. Just a moment. Okay, just a moment. Okay, so as I said earlier, okay, this is an object, okay, and it moves along a straight line. Okay, so tell me, this is the size of the object, right? Length and breadth. Okay, and this is the distance it covers. Let's say this is A and this is B. So tell me whether the size of the objects, that is this object's length, will be equal, okay, or will it be, less than or greater than AB. AB is the distance it covers, okay, the distance the object covers, from A to B. So the object covers the distance of A to B. Okay, so this is the object. Okay, so this object's length, okay, whether this object's size, no, that is the length. Okay, this object's size will be, equal to the distance it covers. If distance it covers is AB, okay, whether it will be equal to the distance it covers, whether it will be less than the distance it covers, or it will be greater than the distance it covers. Which is the right option?
Less than, sir.
Okay, very good. So it it is less than the distance it covers, right? So the size of the object, sorry. So the size of the object is, okay, is less than the distance it covers, right? Is it right or not? The size of the object is less than the distance it covers or not?
Yes, sir.
Yes. So can we call this object as a point object?
Yes, sir.
Yes. So we can call this object as a point object. So get it right. So there are two conditions to consider a object as a point object. One is it should travel along a straight line. Second condition is this: the size of the object should be less than the distance it covers. Okay. Right. So we'll see one of your exercises. So in which of the following examples of motion can the body be considered approximately a point object? So there are four options. Okay, so in they have given four situations actually. So in which of these examples of motion can the body be considered approximately a point object? Okay, so first one is a railway carriage moving without jerks between two stations. So the object is, that is the object we are talking about here, is a railway carriage. Okay, and a monkey sitting on a top of a cycling, okay, smoothly on a circular track. Okay, so the monkey is the object here. A spinning cricket ball that turns sharply on hitting the ground. So the cricket ball is a object here. And finally, D option, a tumbling beaker that has slipped off the edge of a table. So the beaker is the object here in this situation. So in which of these following four examples of motion can the body be considered approximately a point object? Tell us, ma. Anyone?
In the first option, sir.
First option, very good. First option, very good. Why? And explain why it is not B, C, D, and D. And I'll just call out the name. Okay. So the students I call out, you have to give out a reason. So why the other three options are not correct? So let's go with Disha first. Disha, could you explain why B is not cannot be considered as a point object? Disha, are you there?
Hello, sir.
Yes. Yes, ma. So just tell me why B is actually, A is the correct answer. I think it was told by Auxilia. Okay. So just tell me why B is not the right answer. Just use your idea. No problem with that. Okay.
Sir,
Yes.
Sir, the value of distance covered is much greater.
The value of distance covered is much greater. Okay, but there's a fundamental thing there is. So what are the conditions, Disha? Tell me, what are the conditions for a point object? Tell me that. Two conditions I have told.
So, yeah, it
First
has
one
to
is,
be smaller than the distance covered.
that is the second condition. What is the first condition?
Motion is along a straight line.
Very good. Motion should be along a straight line. Here the monkey is sitting on the top of a man cycling smoothly on a circular track, right?
Circular.
So it cannot
Yes,
be a
sir.
point object, right?
Yes, sir.
Okay, so everybody get it?
Yes, sir.
Okay,
Yes, sir.
right. Okay, so I'm gonna call out Shruti. Why C is not a correct option? Do we have Shruti here? I think she has sent a message. Just a moment. Okay, I think maybe her mic is some. I think some problem will be there. Okay, so what about Jayashri?
Sir,
Yes.
it turns sharply on the ground, sir.
Okay, a spinning cricket ball that turns sharply on hitting the ground.
Mm.
Okay, so yes, why could it not be considered as a point object?
Sir, in a first point, motion in a straight line, sir,
Yes. Okay.
but it turns.
Okay. So a spinning cricket ball that turns sharply on hitting the ground, right?
Yes, sir.
Okay. And here we can look at the size, the second condition, no? So the size of the object, what is the size of the object? That is a cricket ball size. That is the object, no?
Yeah. Yes, sir.
Okay.
Circular.
Yes. And let's say if I'm just bowling it in a straight line. Okay. I'm just bowling it in a straight line. So what will happen about the second condition I'm telling you? See, the second condition is what? The size of the object should be less, right? Less than the distance it covers. So what happens here? Does it satisfy the second condition? Jayashri, what you said is right, ma. Okay, the first condition you have told. Okay, so it is not in a
Yes, sir.
straight line because
Yes, sir.
it has spinned, bro. How will the spinning cricket ball? How it will go? It will touch one. It will touch. Sorry. So it will touch one area, right? Let's say it pitches here, and it will just go in other directions, right? So
Yes, sir.
it cannot be on a straight line. So that is okay.
Yes, sir.
I'm just asking whether it satisfies the second condition or not. So first condition actually you said okay, so that's why it cannot be considered as a point object. Okay. So what if it is a straight? Let's say. So I'm just saying that the cricket ball did not spin at all. Okay. So it is a straight. Let's say it's a full toss. You know full toss, right?
Yes, sir.
Okay. So it is a full toss. So what happens here? It is a straight line. So full toss will be a straight ball, right?
Yes, sir.
Okay. If that's the case, will it be a point object or not?
Please say again, sir.
Okay. Here it says it's a spinning cricket ball, right? I'm just giving you a situation where the ball does not spin, okay, and it does not turn also. Okay, I'm just saying this is a cricket ground. Okay, you're just bowling it in a straight manner. Okay,
Okay, sir. Okay,
so
sir.
in that situation, what will happen? Is
The
it a
ball
point
will
object or not?
not, sir.
Not a point object. Why?
It goes anyway.
Excuse me, ma.
Sir, it won't go a straight line.
Uh, okay. Like I said that I'm going to bowl it in a straight manner only. No. Let's say there is no batsman here. Okay.
Okay, sir.
I'm just practicing. So I'm just bowling. I'm just bowling it in a straight manner. So the ball does not turn. It goes in a straight way. So what happens when it does that?
Sir, but ball
Ball?
surrounds, sir.
No, no. Ball surrounds. What are you saying? See, she has told me that there is a spinning cricket ball, okay, and it turns sharply, right? So it is not in a straight line, as he said, as she said, it is right. So okay, I'm just giving you a situation where the ball did not spin and it's a full toss ball, like a straight. I'm just bowling it in a straight path, okay. So it does not turn also because it's not a spin ball, so it does not turn on hitting the ground. So is it a point object or not?
It is a point object.
Very good. Why? Because it is in a straight line only, no? The ball
Yes,
does
sir.
not spin. Okay.
Okay,
And the
sir.
distance it covers is
Is more than
more than
its
the size of the
size.
object. Very good. Very good. Right. So what about D? A tumbling beaker that slipped off the edge of a table.
It is not a point object
And why not?
because it does not go in a straight line
Okay. Why it is not in a straight line?
because it is tumbling. It just falls off.
Okay. Falls off in a straight manner or
Tumbling in the sense it's rotating and falling, no, sir.
okay, okay. It's rotating and falling. Okay. Um okay, but the object is beaker, right?
Yes, sir.
Okay. So whether that the beaker has slipped off the edge of a table, right?
Yes,
So
sir.
yeah, it falls down to the ground, right?
Okay, it falls just like that, sir, like in a straight manner.
Yeah, I'm just asking you whether it falls in a straight manner or not.
Yeah, yes, sir.
Okay. So why is it not a point object?
Sir, I have no idea.
Yeah. See, the tumbling beaker, no, they have said the beaker only, okay, but they have not mentioned the size and all, okay, and the beaker could be of any size. You understand, no?
Yes, sir.
So let's say if the table is like this, okay, this is the ground, this is the table, okay. Um, you have seen no like large beakers are there. You're aware of
Yes,
that,
sir.
right? Okay.
Yes, sir.
What if that beaker is somewhat like this size? Okay. So even if it falls down, okay, the size of the beaker can be large than the distance it covers. You understand?
Yes, sir.
So there is a probability. If this is a small beaker, you can say whether okay, it cannot be considered as a if it is a small beaker, you can say that it is a point object. Okay, because the size of the beaker is less than the distance it covers. That is from the table to the ground. Okay. from the table to the ground. Okay, but the the beaker is of many sizes. Actually, it could be a large size also. So if it is a large size like this one here, okay, so even if it falls down, the size of the beaker is large, right, when it compares to the distance it covers. You getting my point?
Yes, sir.
Okay, so always remember, even when a ball is when a ball is projected upwards, or it upwards, or a ball is projected downwards, it is a straight line motion only. Okay.
Yes, sir.
Okay, so just keep that in mind. And for the validation of the first point, that is a railway carriage moving without jerks between two stations. What is a railway carriage? It is not the whole train, right? Just a railway carriage, right? And the
Yes.
distance, yes, and the distance between the two stations will be large, right? So this is the station 1 S1, or this station 2 S2, means the railway carriage will be like this. Okay, so this distance is larger than the carriage distance, so that is the carriage size, right? So it is, yes, so it can be considered as a point object. Okay,
Yes, sir.
right, so we'll go to the next point. So what is motion? Motion nothing but change in position of an object with time. So how to specify this position? So we know that motion is nothing but a change in position of an object with time. Okay, so how to specify or measure this position? Okay, so for that we need two things. One is a reference point, and another thing is a set of axes. Okay, one is a reference point and a set of axes. Okay, so we are going to take a rectangular coordinate system, rectangular coordinate system, okay, consisting of three mutually perpendicular axes. That the rectangular coordinate systems will be like this, no? So this is going to be y-axis, this is going to be x-axis, and this is going to be z-axis. So this is a rectangular coordinate system with three mutually perpendicular axes, and the point of intersection of these three axes is nothing but the origin. Okay, and it is nothing but the reference point. This is going to serve as a reference point. Okay, so to specify position, we are going to choose a set of axes, that is x, y, and z, three mutually perpendicular axes, and a reference point. Reference point is nothing but a origin, that is the intersection of x, y, and z. Okay, this one, this O, that is the origin, so that is the reference point. Okay, so this three mutually perpendicular axis and a reference point, okay, that is O. Okay, and the coordinates. So what are the coordinates? X, y, and z. No, this coordinates 2, 3, 4, like this. The x coordinate is a y coordinate, and there is a z coordinate. Okay, so if there is a change in this, if one or two coordinates, where if there is a change, if there is a movement along the x coordinate, then we can say that the object is moving along the x-axis. And if there is a movement along, if there is a change in if there is a movement along y coordinate, okay, then we can say that the object is moving along the y coordinate. Okay, and same applies to the z coordinate. Okay, that is the z axis. Okay, so if if two or more coordinates, there is one or more coordinates change with time, okay, then we say that the object is in motion. For example, I say this is the object. Okay, so here here we are going to I'll say it's the example. So this is an object. Okay, so this is an object. Okay, and this is the three mutually perpendicular axes, that is y, x, and z, This is the origin O. Okay, so as I said, these are the x coordinates and these are the z coordinates and these are the y coordinates. Okay, so this entire system, okay, in this entire system we are going to place a clock here to measure time. We are going to place a clock here to measure the time. So this whole system, that is the set of coordinates, that is the set of axis, reference point, the clock, constitute a frame of reference. Okay, frame of reference is nothing but with respect to this object or this point, that this object is in motion. Okay, so for example, okay, let's say auxilia, I'm just taking you, okay, let's say this is auxilia. Okay, so this is the object, she's observing this object. Okay, this is auxilia and this is the object, she's observing this object. Okay, so according to auxilia, okay, this is, sorry, so according to auxilia, this is, you know, the x-axis, this is the y-axis and this is the z-axis. Okay, so this is the origin frame, that is the reference point. So after some time, 2 or 3 seconds, you know, the object is moved from here to here. Okay, so what happens, what can we say about this object? Let's say it is at 0 seconds it has been here, at 3 seconds it has come here. So what can we say, how can we describe this motion of this object?
Motion has the object has traveled along the x coordinates.
Yes, the motion, the position of the object is changing along the x-axis. Okay, why we are saying it is changing along the x-axis? Because the x coordinate, there is a changes in the x coordinate. Okay, okay, so for okay, who is the frame of reference here? Who or which is the frame of reference for this particular motion? Who? Who? Any guesses? Any guesses? Come on, concept is very important for JEE and NEET. Okay, so yes, come on, who's the frame of reference here?
Sir, is it me, sir?
Yes, very good, you are the frame of reference. Like, according to you, okay, with respect to you or according to you, this is the reference point, right, Auxilia? This is the
Yes.
reference point, and according to you, the you know, this object's x coordinate changes from here to here. So that's why you're saying, according to you, this object is moving along the x-axis, right? What if the object is moving from here to here? What you will say? These are the y coordinates. That according to you, the object is moving along the y-axis, right?
Yes, sir.
So everybody get it?
Yes, sir.
So
Sir.
yeah, so the frame of reference is nothing but the observer. Okay, the frame of reference. For example, we can say like, you know, when we are, you know, when we are witnessing a car, when we are, you know, let's say this is a car, okay, and we are observing it. Okay, the car, you know, its position changes with time, that is, it is in motion. Okay, so it goes from here to here and here to here. Okay, so we can say the car is in motion, right? You can say that the car is in motion according to the frame of reference. This is the frame of reference attached to this person. Okay, according to this person, that this object, that is the object, by means I'm saying it is a car, it changes its position. Okay, let's say in a straight line, okay, at a distance there is another person. We can say, can we say Disha? So I can take Disha, I guess. Okay. So according to Disha, maybe she's at a very long distance, okay, from this, from this vehicle. Let's say the vehicle changes position from here to here. Here there is auxilia, so she says it is moving. According to Disha, is it moving or not? It is in a straight line. So according to the frame of reference of auxilia, she says, because she's here, she says the reference, this is a reference point. So from here, the car has changed this position from here to here. Okay. But Disha is here. Okay. So according to her, according to the frame of reference of Disha, can we say that the car is in motion according to Disha? That is according to the frame of reference of Disha.
No, sir.
No. Very good. Because according to her, the object will be at rest, right?
Yes, sir.
Yeah, the object will be at rest. Okay. So it depends upon the frame of reference. Always remember, it depends upon the situation. The situation of auxilia is different. The situation of Disha is different. So you understand?
Yes, sir.
Okay, very good.
Yes.
Yes, right. So for one-dimensional motion means it's nothing but motion along a straight line. Motion in a straight line, or rectilinear motion, or motion along a straight line. Okay. It requires only one axis, say x-axis. Okay. It requires only one axis, that is x-axis. Okay. So to represent like from the introduction I have been telling this, that is, if an object is moving in a straight line, means what I'm doing, I'm just drawing a straight line. That is also what? A x-axis. Okay, for one-dimensional motion. Okay, there is motion in a straight line. For objects moving along a straight line, we can take only one dimension is enough. Okay, so that is one axis is enough. Okay, so for objects moving along a plane, let's say this is a plane. Sorry, let's say this is a plane. Okay, if the object is moving along a plane, we require two axes, that is x and that is x and y. Okay, we need two axes, right? And objects moving along space, in a space, we need three axes. What are they? X, y, and z. So since we are dealing with motion along a straight line, we are going to confine ourselves to single axis, that is x-axis. Okay, right. So in order to describe the motion of an object, we are going to specify some quantities. First is path length. Path length of an object is nothing but a distance traveled by the object. Distance traveled by the object. Okay, so path length is nothing but the distance traveled by the object. Okay, so one of the basic things you should know about path length is, as you already know, it is what? It is a scalar quantity, right? So what is scalar quantity? You have studied in your early classes.
It has only magnitude, sir.
It
No
has,
direction.
yeah, it has only magnitude and no direction. Very good. So since it has no direction, we can say that distance or path length. Okay, distance or path length is always positive. We can say like that. So distance or path length is always positive. Okay, it cannot have negative values, or it cannot have zero values. It is a scalar quantity. It has only magnitude and no direction. In one-dimensional motion, okay, in one-dimensional motion, the direction, okay, the direction can be taken care of. There are only two directions possible in a motion, that is one-dimensional mode, that is motion along a straight line. Only two directions are possible, that is, what are they?
Positive and negatives.
Positive and negative. That is upward, downward, right? Then forward and backward. So upward is nothing but positive, and forward is also positive. Downward is positive. Sorry, downward is negative, and backwards is negative. So there are only two directions for it, that is plus and minus. Okay, positive and negative. Okay, so distance is always positive because it has no direction. Okay, and has only magnitude. Okay, so let's say let's say if I say that is 400 meters, distance is equal to 400 meters. So what can we say? So always, it will have some value and a unit. The scalar quantity will have some value, okay, and a specific unit. Okay, so that is what path length is all about. Okay, right. So we'll take this example. Okay, so this shows that motion of a car. Let's consider this a motion of a car. Okay, so these are the positions of the car, that is 200 meters, 240 meters, 280 meters. These are all positions of the car, and O is nothing but the origin. Okay, and the car was here initially. Okay, this is where the car has started, and R, Q and P are nothing but different positions of the object. Okay, so this 40, 80 and 120 is all nothing but the positions of the object. Okay, so they are saying path length is equal to OP. So the car was here. Okay, it has traveled from O to P. It has traveled from O to P. So what is the path length? That is the distance traveled. That is OP. O to P. What is the distance traveled? Path length is equal to 360 meters, right? 0 to 360. Yeah. Yes, my doubts?
No, sir.
Okay. So the total distance, that is from the position O to P. The car was initially at O and it has traveled to P. Okay, so what is the total path length? That is the total distance traveled. It is nothing but OP. O to P is nothing but 360 meters. Okay, total distance is nothing but 360 meters. That is 40, 80 meter, 120 meter. So likewise, position P is at the 360 meters. Okay, so OP is nothing but the path length, that is 360 meters. Okay, now the second thing is OP plus PQ. The car was here. Okay, so from there it went to O to P. Okay, and from there it went from P to Q. So what is the path length? That is the total distance traveled. Path length is equal to OP plus PQ. What is OP? What is OP?
360, sir.
Yes, 360 meters. Yes, 360 meters. And here, so after completing this 360 meters, the car was here. I just went from here to here, here to here, and it has come here. So what is the distance from P to Q? That is 40 meters, right? Difference 40 meters, 40 meters, and 40 meters. So P to Q is 40, 40, 40. That is 120 meters. So P to Q is nothing but 120 meters. 120 meters. So it's nothing but 480 meters, nothing but the total path length. Okay. Right. So now we'll go to the other quantity. We'll define another quantity, that is displacement. Displacement is nothing but change in position. Yes, change in position. Okay, not change in position with time. Displacement, always keep in mind, displacement is nothing but change in position. Okay, and who was the one that answered right now, just now?
Jayashree, sir.
Jayashree. Okay, so displacement, always remember, displacement is nothing but change in position. Okay,
Okay.
so it is what it is a vector quantity, right? It is a vector quantity. It has magnitude, then it has direction. It has magnitude and direction. Okay. Since it is a vector quantity, it depends upon direction. So what can it have? Distance is always positive. What about displacement?
It can be both positive and negative.
Yes, it can be positive, negative, and also even can be zero also. Can have null value also. Okay. So displacement can be
Okay, sir.
positive, negative, and nil values also. So how to denote this displacement is nothing but displacement nothing but change in position, right? It is denoted by del x. X is nothing but position. Delta is nothing but change in quantity. Change in quantity. So what is displacement? Displacement is nothing but change in position. Okay. So when we say change in position, what you have to write? Del x. X is the position. Delta is nothing but a change in quantity. Okay. All right. So displacement is nothing but del x. Del x is equal to x2 minus x1. x2 minus x1. x2 is nothing but the final position of an object. Final position of an object. Okay. x1 is nothing but initial position of the object. Initial position of the object. So displacement is nothing but change in position, which is nothing but del x. Okay. Del x. So displacement can be written as difference between final and initial positions of the object, right? Correct or not?
Yes, sir.
Yeah, displacement is a change in position. Changes in position is nothing but del x. Del x is equal to x2 minus x1. x2 is nothing but the final position of the object. x1 is nothing but the initial position of the object. So displacement is nothing but the difference between the final and initial positions of the object. Okay. So when can this displacement have um, you know uh, displacement is dependent on direction because the vector quantity, and as we already said, in one dimensional motion, that is motion along a straight line, direction can be taken care of plus and minus signs, right? So when will be the displacement be positive? When the displacement can be positive? When will it be positive? Displacement is nothing but del x is equal to x2 minus x1. So displacement can be positive if x2 is greater than x1, right? It yields a positive value, right?
Yes, sir.
Okay. So when will be the displacement be negative? When the final position is less
Yes,
than the x1.
One.
Yes, that it will yield a negative value.
Negative.
Very good. So when will the displacement be 0?
When final position
both are
coincides
equal.
with the initial
Yes,
position.
final position coincide with the initial position, or final position is equal to the initial position.
Initial position.
So displacement can have 0, then positive and negative values. Okay. So for the same operation, that is, for the motion of a car, we are going to calculate displacement. Okay. So what is OP? That is O to P. Okay. That is, here it is the initial position of the car, and this is the final position of the car. So what is displacement? What is displacement? Del x is equal to x2 minus x1. What is x2? Which is the final position?
360, sir.
360. Very good. x1 is
0.
0. So what is the value? 360 meter. And here distance is also for OP is 360 meter, and here displacement for the motion O to P is also 360 meters. Okay. And when distance, so we can write as distance is equal to displacement, no? Distance is equal to, we can write like this, no? For this, for this particular operation, that is for this particular motion O to P, right?
Yes, sir.
Yes. And when that will come, that when distance will be equal to displacement. There are also two conditions, remember it. So with this we'll wind up the class, we'll continue from Monday. Okay, so for distance to be equal to displacement, or displacement to be equal to distance, there are two conditions. One is that the motion should be along a straight line, along a straight line. Then the motion should be along positive direction. Okay, so when can the distance will be equal to displacement, or displacement will be equal to distance? And the motion is along a straight line, first condition, and the motion should be along the positive direction. So here from O to P, is O to P